computer program is a list of instructions that can be followed by a computer to perform a specific task. Most programs work by taking some input data, processing that, and creating some output data. Understanding the values and types will form a foundation on top of which we can build up concepts that will allow us to write our own programs. So values are the actual underlying raw numbers and text our program manipulates. Tony Stark, the number 43, and false are all examples of values. Sometimes we'll say that when we literally write the number 4 and then the number 3 next to each other to form the number 43, that we're writing the literal 43. Same with Tony Stark. If we write the quotes, then the letters T, O, N, Y, etc. into our code, we'd say that we're using the string literal Tony Stark. Sometimes we might say that this is hard-coded, meaning that when the program runs, the literal value isn't going to change. Literal values are used a lot when you're first starting out, but eventually data will likely come from a database or some user input. Every value belongs to exactly one data type. The kinds of values that can be represented and manipulated in a programming language are known as types. All of these literals that we've written so far can be categorized as a specific type. We see string, number, and Boolean. Those are the types for Tony Stark, 43, and false. Most languages use a very similar list of super simple types, like a collection of characters as a string of text, a list of digits with or without a decimal point as a number, and then some type for representing true and false. Some programming languages will have more types that they have built in. Other programming languages will have a very small set of these primitive built-in types that you are to use to build up to more complex types. When a program needs to use a value again in the future, it assigns that value, or sort of like stores that value, in a variable. Variables have names, and they allow us to use those names in our programs to refer back to the values. We'll talk more about variables later. Here we're assigning the value 7 a name, age. We're also assigning the string Grayson to the variable name first name. If we wanted to print out the value 7 using the variable age, we might call some print function and pass in the variable name or the literal number 7. And we'll take a look at how to print out the number or the string or whatever value it is in different programming languages. There's really two different kinds of types. There are built-in types, and then there are user-defined types. Built-in types are the types that come with the language. This is the batteries included stuff like numbers and strings and dates and arrays and object types. User-defined data types are defined in terms of built-in data types and other user-defined data types. Here, we're defining a student type, or we have defined a user-defined type called a student type, which is composed of or made up of other built-in types, the number for the age and the string for the first name. We might also create a car type, which takes in a make and a model, both of which might also be user-defined types. Typically, a programming language does not let the programmer extend or redefine those built-in types. Next, a type can either be mutable or immutable. These primitive types like 7 and true are immutable, meaning they cannot change. You can change the value of the variable, meaning you can change what the name of that variable is referencing by pointing the variable at a different value. However, there's no way to change what the number 7 means. When we talk about the number 7, there's no way we can modify the number 7 to be the number 8 or the number 6. We wouldn't want to change what the number 7 means. Similarly with true, we wouldn't want to change what it means for something to be true. A mutable object can change. Here we have an array or a list, And this list has 4 values. It has 9, 10, 9, and 11. These might be ages or these might be other values, but the underlying type for this collection of values is called a list. A list or an array in some languages can change. Let's take a look at how we can work with values and types in Python. I'm using Replit today. First, let's learn how to print out something to the console. So on the right-hand tab here, we'll call this the console, and the left-hand tab, we will call this our editor. We're currently in the main.py file in our editor, and the first thing I want to do is show how to print a value. So let's do print 1. So I'm writing the word print. This is a built-in method in Python. Then I'm using the parentheses to indicate that I am executing the print method, and I'm passing in this literal value 1. So we talked about how values can be numbers, and the number 1 is a valid number. Within the Replit interface, we have a run button, which we can click to execute our program. When we click run, the Python interpreter will read our one-line program and execute that one-line program, printing the output to the console here on the right. So let's click run, and we'll see that 1 was printed out on the right. We can change 1 to our number 43 from the example, and we'll see that that is also printed out on the right. Now there's other things that we can do within this editor to view the output. But one thing I want to show is that you can add comments. In Python, we add comments by placing an octothorpe at the beginning of the line that we want to comment out, or at the beginning of the part that we want to comment out. A comment in a programming language is a way to describe or to add some information to the programmer about the code that's running, but it's also a way to indicate a certain portion of the code that should not actually execute. So if I add this octothorpe or the pound sign at the beginning before the print command, and then I try to run the code again, it's as if there is no code here at all. So I'm going to use comments to keep track of things that we've experimented with before, and so that you can go back and reference these later. So we have our first line on line 1. We showed how to print out the number 43. So I've commented out the number, or the print statement that will print the number 43. Let's try printing something else out. So we also talked about printing Tony Stark, right? So if we say print and then we pass in Tony Stark like this and click run, we'll see this fails. And the error here on the right is really important. We want to get comfortable reading these error messages. So we see in the file main.py, so that's the file we're working in now, on line 2, so line 2 here, we have the print statement Tony Stark, and there's a little caret here that tries to tell us where it thinks the error might be. And we see this is a syntax error. We have invalid syntax. So Python, when it's trying to execute the code, said, hey, this is not valid Python code. So we attempted to print out the string Tony Stark, but Python doesn't know where the string of characters starts and where it ends. And that's why we need to use quotes. So we always have to wrap our strings in some type of quote that is indicating that it is a string. In Python, strings can be wrapped in either single quotes or double quotes. So here we're saying print, and now we have wrapped the name Tony Stark in single quotes. So if we execute the program again by clicking run, we'll see that now we're printing out Tony Stark. If we use a double quote at the beginning and a single quote at the end, that will also fail because the quotes need to match. So if we use a double quote in the beginning, we need to use a double quote at the end. It is a common practice in Python to use single quotes everywhere. So we will use single quotes and print out Tony Stark. Okay, so that is great. I'm going to comment that out and we'll move on to the next example. This time, let's print out the value false. Okay, so in Python, the Boolean values available are true and false, and they are both capitalized. So we're going to use the print method again. We're going to pass in the value false. So if we run this, we see that we get back false. Great. Let's take a look at a couple other things that we can do. So one thing that might be interesting with numbers is to show that you can do arithmetic directly in an expression that is evaluated before being passed to the print method. So we can say 43 followed by the plus operator. So this is called an operator. And the number that we want to add to it. So if we say 43 plus 10, then this bit of code here, the literal 43, followed by the plus operator, followed by the number 10, this is referred to as an expression. The expression will be evaluated, and then the resulting value from the expression, which will be 53, is going to be then passed into the print function and will be printed to our console. So here when we run the code, we get 53 back, and that is the evaluation of the expression 43 plus 10. So you can kind of think of this as what's happening is like step one. Let's see here. So we have step one is we evaluate the expression 43 plus 10. Step two is to replace expression with the value 53. Step three is to execute the print function. Sometimes we say function, sometimes we say method, and we will disambiguate those depending on the language. So for now, we'll just say this is the print function. So the first thing that happens is we kind of like break out this 43 plus 10. So this happens first, and that gets replaced by 53, right? Because that equals 53. So that's kind of like step one will evaluate this expression. Then step two is going to like replace it with 53, and then step three is going to actually execute print and print that out. So here is some more examples of things that we might do with values. So we might say print, and then we want to say Tony. Maybe we have the first name and the second and the last name separately. So we might say Tony plus Stark. So when we're using strings and not numbers, so with numbers, we know what the plus operator will do. The plus operator will take the value of the first number literal and add it to the value of the second number literal. With strings, we're going to concatenate. Concatenate means to link together things in a series. So we are going to link together the string literal Tony with the string literal Stark. So we are going to smash these two together, and they will create a new string. So this time in step one, when we're evaluating the expression Tony plus Stark, the first thing we're going to do is evaluate that expression and concatenate those two strings. Then we'll print out the result or the value that is yielded by combining Tony and Stark. So if we click run, we'll see that we get Tony Stark. But now it is all one word because we have no space. The two strings that we concatenated together do not contain any white space. So here when we printed the original Tony Stark, we had Tony space Stark. So space and white space is important. So here what we might do is say Tony space plus Stark. By adding the space to the first name, we end up with a space in between the first name and the second name. Another alternative would be to concatenate Tony and Stark with a space in between them. So we can create a string that is just a single space, and we concatenate the first name, a space, and then the last name. So this is one other way that we can use string concatenation to print out a string that is like a combination of a couple different things. Other things that we can do with values, we can look at and inspect the type of a value. So if we say type in Python and pass in some value like Tony, we will get back the type information about the value that we passed into type. So when we run this, we'll see that the type of the string Tony is a string. So we'll see here that the what we printed out has these angle brackets, and it says class and it says str. So the class in Python that represents the type for this string literal is str. So str in Python is the type for a string. It turns out in Python there are technically four types of numeric values. We have the most simple we've already talked about, which is Boolean, false and true. That is a subtype of a numeric. We would almost always just refer to those with their false and true values with the capital F and capital T, false and true. The next type we've talked about already is an integer type, which is just a number that we know and love, a whole number, 43, 1, 5,862. These are all integer types. The next two are called float and complex type. Floating point numbers are more common, and so most of the time when we're working with numbers, we're going to be working with integers or floats. So I want to just show one quick example of a floating point number. We can say 43.0. That is an example of a float because it has a decimal. There is some decimal value. Even though the decimal is 0, by typing in 0.0 in our literal for 43, we will get back a floating point number.